What is diode?
Diode is a semiconductor device. Imagine diode is like an electrical valve that allows current to flow in one direction with far greater ease than in the other. A diode has two terminals, a plus terminal called anode and a minus terminal called cathode. This is the schematic symbol of a diode. The arrow is pointing in the direction of the current, as opposed to the flow of electrons. I usually think of the vertical line at the pointy end of the arrow as it resembles a sideway minus sign. That is the cathode of the diode.
How does a diode works?
An N-type semiconductor block will have a significant number of free electrons. And very little number of holes. Holes present in N-type semiconductor due to generation of electron-hole pairs mainly caused by thermal excitation. A P-type semiconductor block will have a significant number of holes. And very little number of free electrons. Free electrons present in P-type semiconductor due to generation of electron-hole pairs mainly caused by thermal excitation. Let us create a simple p-n junction diode. Let us join an N-type and a P-type material together. The majority carriers in N-type material are free electrons. The majority carriers in P-type material are holes. Let us see what happens at the junction of these two materials. Adjacent to this junction edge, free electrons in the N-type material will recombine with holes in the P-type material. As a result, there will be lack of free electrons and holes across this region. This region is called depletion region. We know that an N-type material is electrically neutral because the number of free electrons and positive donor ions are same in an isolated N-type material. Similarly, a P-type material is electrically neutral because the number of holes and negative acceptor ions are same in an isolated P-type material. After absorption of free electrons in N-type side of in depletion region, uncovered positive donor ions will remain there. After absorption of holes in P-type side of in depletion region, uncovered negative acceptor ions will remain there. This region of uncovered positive and negative ions is called the depletion region due to the depletion of free carriers in the region. Due to the presence of these positive and negative ions, a static electric field called as barrier potential is created across the junction. It is called as barrier potential because it acts as a barrier and opposes the further migration of holes and electrons across the junction. Now, we connect link to the ends of each material. We made the basic p-n junction diode. Now, we connect positive terminal of the voltage source to the link connected to P-type side. And, we connect negative terminal of the voltage source to the link connected to N-type side. In this condition, diode is said to be in forward biased condition. We already told that there is a barrier potential across the junction. This barrier potential acts in the opposite of the forward applied voltage. So, there is no forward current through the diode unless the magnitude of the applied voltage becomes more than that of barrier potential. This voltage we refer as forward biased voltage.
Forward bias, reverse bias.
Let's connect the diode in series with a lamp. When connected this way, the lamp light up indicates that there's a current flowing through the lamp. In this case, the diode is said to be forward biased. But if I reverse the diode, the lamp won't light up because the diode prevents the current from flowing. This is where the diode is said to be reverse biased.
Typical forward voltage for diodes.
For a typical diode, a certain amount of forward voltage required before any current will flow. This minimum threshold of voltage is called forward voltage drop. For typical silicon diodes, this forward voltage drop is around 0.6 volt. Anyway, the ability of a diode to withstand reverse bias is limited. If the applied reverse bias voltage is large enough, the diode will break down. And when that happens, there's a good chance the diode is damaged. You can look in the diode's datasheet for the peak reverse voltage value. That is the maximum reverse bias voltage that the particular diode can withstand. The datasheet also indicates the maximum current ratings. Make sure your diode isn't exposed to more than these ratings, or you'll risk permanently damage the diode.
Types of diodes. There are a lot of different types of diodes. Let's go through some of the common ones. Light emitting diode.
LEDs light emitting diodes are everywhere. They come in a wide variety of colors and are found in places like automobile dashboard and clock wearables. Many mixed-rate projects involve circuits that include LEDs. So let's take a look at how an LED works. A diode is an electrical component that allows current to flow in one direction. In an LED, the longer leg is the anode or positive leg, and the shorter leg is the cathode or negative leg. And the electricity can only flow from anode to cathode. So, if you put your LED in backward in circuit, it won't light up. The component inside the LED has special properties that allow them to emit light. Electrical components fall into one of three categories: insulators, which don't allow electricity to flow to them; conductors, which allow for the free flow of electricity; and semiconductors, which fall somewhere in between. An LED contains two types of semiconductor material. There is P-type semiconductor, which contains positively charged gold. The N-type semiconductor contains negatively charged electrons. As the electricity tries to flow from anode to cathode through the semiconductor materials, the host and the electron react, and they begin moving each other when they interact with one another. Energy is released. That energy released in the form of light, and that is what we're seeing when LED ups.
Thanks for watching.